Students, welcome to Geometry Module 6, Lesson 1, Finding Unknown Angles in Geometrical Figures, Squares, Rectangle, and Triangles. Just in case you're hearing the rumbling outside, it's the thunder. It is going to rain crazy in Singapore where this recording is done. But guess what? No thunder is going to stop us from learning geometry today. Calculators are allowed, by the way. Okay, moving on. This topic covers finding unknown angles in various geometrical figures, some of which you may remember from before. We'll go through a few examples and you'll be ready to take on any kind of questions that come your way. Okay, students, before we jump into the excitement called geometry, let us define some of these expressions to help us comprehend this topic a lot better. What is a right-angled triangle? A right-angled triangle is one where one angle is 90 degrees. As long as you have one angle in a triangle which is 90 degrees, it is known as a right-angled triangle. The one I'm pointing at right now with this fancy green arrow. What is an isosceles triangle? An isosceles triangle is a triangle with two equal sides forming two equal base angles. These are the two equal sides. These are the two base angles. They will always be equal. You see these lines over here, there's little perpendicular lines. This means that these two sides are of the same length. That's how you identify an isosceles triangle. What is an equilateral triangle? That is a triangle with three equal sides. Okay, three equal sides. If you see three lines like that, it is an isosceles triangle and the angles will always be 60 degrees. The three angles will always be 60 degrees. The objectives of this lesson. Objective number 1, find unknown angles in squares. 2, find unknown angles in rectangles. 3, find unknown angles in triangles. There are 3 topics that you may have to revisit. Okay, these could be from your earlier grades. Sum of angles on a straight line, 1. 2, sum of angles at a point. 3, vertically opposite angles. Okay, students, I need you to remember this. Remember that it is just as important to read the question carefully as it is to examine the diagrams, because some of the information needed may not always be shown in these diagrams. Okay, with that in mind, let's get straight to it. Question 1. In the following figure, not drawn to scale, ABEF, follow the cool red light. ABEF is a square and BCDE is a rectangle. L is the midpoint of AF. This is AF and L is the midpoint. And LMN, this line right here, is a straight line. With all this information given, find angle ABF and angle CDN. Okay, what do we know about squares? The thing we need to know about squares and rectangles is that all 4 angles are right angles. In this case, we can see that the diagonal line BF, which is this line right here, BF, it cuts the square ABEF. It cuts this square ABEF into half. If it cuts the square into half, and we know that this is a right angle initially, then we can easily find ABF. So step 1 is this. Okay, angle ABF, as discussed. Because the square was cut into half, all you have to do is take 90 degrees and divide it by 2. 90 degrees divided by 2 and you get the answer is 45 degrees. Right? What's the reasoning? The reasoning is angles of a square. That's the reasoning. And remember, at this level, you always have to know the reason of why you get the answer. You can't just write the answer without the reason, okay? Now, moving on, let's find angle CDN. But before we find CDN, we've got to first need to find LDC. LDC. So we need to find LDC first. LDC first. And then we will be able to solve for the angle CDN using the reasoning as angles of a straight line. So what is the information we need here? We need this information, which is 18 degrees. With this information, we can solve for LDC. Solving for angle LDC. As I pointed out earlier, you take 90 degrees and you minus 18 And you get 90 minus 18, 72 degrees. Angles of a rectangle is the reasoning. We have also previously learned that angles on a straight line add up to 180 degrees. Therefore, we can work it out as follows. This brings us to step 3, which is to solve for angle CDN. Angle CDN, which is going to be 180 degrees minus 72 degrees. You know 72 degrees from where? From angle LDC, right? So it is angles on a straight line. So 180 minus 72 is 108 degrees. That's your final answer for angle CDN. And the reasoning is angles on a straight line. Angles on a straight line. Always remember to write your reasonings down. And these are your answers. Okay, 45 degrees and 108 degrees. Moving on. Students, let's look at question 2. In the following figure, not drawn to scale, angle ABC is a right angle triangle. ABC is a right angle triangle. And CEF, this one right here, CEF is an equilateral triangle. Angle DCE, this one right here, this angle is 95 degrees. And BCD, this is a straight line. Find BAC. This one right here, find this value. Okay, now based on the information given to us, let's fill in as much as we know into the figure. Okay, let's fill up as much as we know into the figure. Let's just put a question mark where angle BAC is. Okay, that's a question mark, and that's what we are looking for. Now let's fill up the information we know. We already know DCE is 95 degrees. The right angle triangle there, that is what? 90 degrees. We know that. 90 degrees. And then let's look at the equilateral triangle. That information is given to us. Let's draw the perpendicular line first to indicate that it is an equilateral triangle. Let's fill in the figures now. What's the angle? Within an equilateral triangle is always all the angles would be 60 degrees. All these angles are 60 degrees, right? Now, what is the method to find angle BAC then? It is going to be what? Angles within a triangle, right? All angles, sum of a triangle is going to be the rule. But the thing is, there's one angle missing. Okay, angle BCA is missing, or angle ACB is missing, right? Angle ACB is missing. Therefore, we've got to find that first. And that is going to be easy to find because we pretty much know all the values. So let's do angle ACB equals to 180 degrees minus angle DCE, which is 95 degrees, minus angle ECF, which is 60 degrees. And this, what do you get from there? You get 25 degrees. You get 25 degrees. And what is the reasoning? Angles along a straight line. Angles on a straight line. And in any triangles, the three angles will add up to 180 degrees. You know this information, a principle known as angle sum of triangle. Based on this, we can find angle BAC. We know the 90 degrees and we know the other one we just found out, which is 25 degrees. So let's add all of them up. So we'll take 180 degrees, not add, we will subtract it, sorry. We'll take 180 degrees minus 90 degrees and we'll minus 25 degrees, which is angle BCA. Okay, what is the remainder we get? We get 65 degrees. What's the reasoning though? The reasoning is angle sum of a triangle. Angle sum of a triangle. So your correct answer is 65 degrees. That's your final answer as well. And we are done with question 2. Question 3, last question of this lesson. In the following figure, not drawn to scale, PQR is an isosceles triangle where PQ is equals to PR, which is exactly the property of an isosceles triangle. And angle QPR, this angle right here is given 94 degrees. PRT, this is a straight line. QRS is also a straight line. And angle RST, this one right here, is given 100 degrees. So with all this information given, what they're asking us to do is find X. We are looking for X. And we can see automatically that if you take 360 degrees and subtract it with angle T, angle T, you will get the answer. Okay, so with all the information that is given to us, let's fill in as much information as we know. Since we know that the base angles of an isosceles triangle are equal and the angle sum of triangle is 180 degrees, we can work out the first part like this. Step 1 is going to be like this. Angle PQR, which is also equal to angle PRQ, because it is an isosceles triangle, is going to be equals to 180 degrees minus 94 divided by 2, right? Angle PQR and PRQ are the same because it is an isosceles triangle, and the answer you get is 43 degrees. What is the reasoning? The reasoning is angle sum of a triangle. And we also know this. We also know that vertically opposite angles are equal. Vertically opposite angles are equal. Vertically opposite angles are equal, which means this equals to this. This is equals to this. Vertically opposite angles are equal. Therefore, we can fill in that information as well, which means angle is that what? TRS. TRS is 43 degrees. Okay, we know that information as well. Using the principle of angle sum of triangle again, we can find RTS. So let's move on to find RTS. Actually, before we move on, let's do this. Let's fill up the values of PQR and PRQ first. Okay, 43 degrees and 43 degrees, right? We already solved for them. And it's an isosceles triangle, so let's draw the little perpendicular indicators over there. Okay, now moving on, we can solve for angle what? RTS. RTS is going to be 180 degrees minus angle RST, which is 100 degrees, minus angle TRS, which is 43 degrees, which we just solved for earlier on. And what's the reasoning? What's the answer first? Let's solve for the answer, and we get 37 degrees. The reasoning is angle sum of a triangle again. Okay, now to find x, we use another principle we previously learned, which is that angles at a point, okay, angles at a point add up to, okay, angles at this point, angles at a point add up to 360 degrees. So angle x is going to be equal to what? Angle x is going to be equal to 360 degrees minus 37 degrees, which is angle RTS. And what's the answer you get? You get the answer of angle 323 degrees. And what's your reasoning? Angles at a point. Angles at a point. And that is actually your final answer. You've just solved for angle x. Well done. Geometry lesson 1 completed. Go ahead and attempt the quiz, please. And as always, go score.